All right, so now, boys, now we're starting to get into the maths of science, okay, where they interconnect. So we're going to calculate work in this lesson. We're going to use these notes. I'd like you to be able to define what work is there. I'd like you to write what units it is there and the formula to work out work there. And on the back, you'll have these questions, which we're going to go through in this lesson. And what I'd like you to do is work them out on the page before I put the answer up, okay? So first, let's start with the definition of work. What is work? Well, work is done only when a force is applied to an object, when a force applied to an object causes the object to move in the same direction as the force. All right, so what this means is if you push an object, the object needs to move, and it needs to move in the same direction you're pushing it, or at least a relatively similar direction to which you're pushing it, okay? So if you push your pencil case or your book in front of you, as you push it forward, you are doing work. If you push on the side of a wall and the wall does not move, I'm sorry to tell you, you did no work. In scientifically speaking, work only happens when you apply a force and the object moves. If the object doesn't move, it doesn't matter how hard the force is, it's not work. All right. So, for work to be done, a force needs to be applied and the object needs to move in the same direction as the force being applied. All right. That's me saying the same thing again. I don't know why I wrote it twice. Okay. So, before we look at how to calculate work, let's recap how to calculate the force. How do you calculate the force required to lift an object? To calculate the force needed to lift an object, you multiply the mass by 10. All right, so before I move on, let's just recap. Work, you apply a force, and when you apply that force, the object has to move. So that's what work is. It's force acting on something over a distance. The object has to move, okay? And you'll see why those two things are important, force and distance, when you start working out. But I'm recapping how to calculate force. So let's say there's a 10 kilogram box on the ground and you pick it up. You need to apply slightly more than the weight of the box. And the weight of the box in newtons is the weight 10 kilograms times by 10, which will give you 100 newtons. So to figure out how much force you have to apply to lift it, you have to take 10 times 10, which are 100 newtons, and that's the force we're going to work with, okay? So let's jump into things. Okay, I'm going to pause here. Let me just, before I rush ahead, okay? I went through everything quickly. If you're still a little confused, go back, but it should make sense with this next slide. Okay, the formula for work is force multiplied by distance the object traveled. All right, so here's another W, work equals force times distance. So that's why in science, the object needs to move when we apply a force. All right, if you push against the wall, no matter how hard you push, the wall isn't going to move. And so no work will be done. So if the distance of the wall moved is 0 meters, and you apply 1,000,000 newtons of force, let me just get all my zeros in there. So you apply 1,000,000 newtons of force, but the wall does not move, you are going to have a total of 0 joules of work done. All right? So that's why we always need the object to move in the same direction to figure out how much work we're doing. All right? And work is measured in this unit here, joules. That's how the full word is spelled, but we just use a capital J. Okay, joules. It's important to remember. So what you should know before we move on to our examples, I'll get to that. Before we move on to our examples, let me recap what you need to know. You need to know that work is force multiplied by distance. That's the formula to work it out. It is measured in joules. And scientifically speaking, work is when a force is applied to an object and it moves in the same direction. That's everything we've covered so far. There's one more thing, and that is remember to keep your calculations in the correct unit. So what I mean by that is when you write a force down, it needs to be in newtons. And when you write down distance, do it in meters, not in centimeters, not in millimeters. Always convert to meters. All right, that should be everything. So let's jump into some practice quickly, okay? Oh, I'm stuck on the slide. There we go. So the force needed to lift the glass of water is about 4 newtons, and the distance is raised about 0.25 meters. How much work is done in raising the glass? All right, so think about it. Work equals force times distance. All right. I'm going to stop, pause it now, and try and figure out the answer. Okay, the answer is 3, 2, 1. The answer is 1 joule of work. Now, how do we get there? Work equals force times distance. Okay, I've mixed it up here, but our distance is 0.25. So 0.25 is our distance, and our force is 4 newtons. Okay, so we don't times that 4 by 10 because it's already in newtons. If you wanted to work out how much that glass weighed, you divide it by 10. Okay, which means it's 0.4 kilograms. That's how heavy the glass is. And what that means is we do 1 joule. 0.25 times by 4 is 1 joule. Sorry if I did not say it. You are allowed to use calculators in this. Okay, I'm not testing your math side. I'm testing your understanding here. But this was a calculation you should have been able to do in your head, because it's another way of saying it is it's 1/4 of 4. Okay, cool. Let's try the next one. The force applied to the rock is about 800 newtons. The rock does not move. How much work is done? Okay, work that out in 3, 2, 1. The answer is 0 joules because the distance is 0 meters. So 800 times 0 is 0 joules. Like we said earlier, the object has to move. Okay, you have asked 3 friends to help you move a rock. Each of you applies 500 newtons of force. Now read that carefully. Each of you, not one person or not all of you together. Each of you applies 500 newtons. So I apply 500, you apply 500, and so on. Of force to the rock, and it moves 1 meter. How much work was done on the rock? Okay, one more thing. Read the beginning of the question. You have asked 3 friends to help you. How many people are pushing on the rock? Use common sense. Use logic. Make Miss Todd Mason proud in the logic of reading that sentence. Okay, pause and give it a shot. Cool. The answer is 2,000 joules. Now, why is that? Well, force, we need to work that out. 500 newtons times by each person that's pushing the rock, and it's 4 people pushing the rock. You and 3 friends. It's not your 3 friends. Like, how lazy would you be if you called 3 friends over to help move a rock, and then you sat back and watched them? Of course, you're helping them. And then you multiply that, which would be, in this case, 2,000. Yeah, so 2,000 newtons of force times by the 1 meter we push it, it's 2,000 joules over here. All right, cool. Let's try another one. Calculate the work done pushing a car 15 meters using 500 newtons of force. All right, pause the video and work it out. Okay. The answer is 7,500 joules. It's the force, 500 newtons, times by the distance, 15 meters, gives you 7,500. All right, I believe this is the last one. Calculate the work done lifting a 100 newton sewing machine from the floor to a tabletop 75 centimeters high. All right, so things to notice. It's already in newtons. That's great. So we don't have to times it by 10. And then, trick is, this one's in centimeters. I'm not going to explain what to do. I think you guys need to try and figure it out. If you don't, I'll tell you the answer. I'll tell you what to do in 5 seconds. All right, if it's in centimeters and you want to convert it to meters, you divide by 100. All right, and the answer is coming up in 3, 2, 1. Work equals force times distance. So force is 100 newtons, distance is 0.75, so it's 75 joules. Okay, that's everything. I hope you feel comfortable with it. Give the questions below a shot. If you're still struggling, then go to read the article that are attached. If you're still struggling, ask your teacher. All right, thanks, boys. Good luck.